Okay, so our graphs are finished. I've got different lines to represent each of my independent variable treatments, and I'm ready to use the simulation to create a model of what was happening at the particle level. So in Amplify Thermal Energy, you can click on the three lines, and that will take you to any of the sims actually, but scroll down till you get to the thermal energy sim. Now, what you do in the simulation is really going to depend on what you did for your experiment. You want to try and recreate a situation similar to your Goldilocks lab. A couple features you can use. So there is a different substances option if you looked at the material of the cup, or we're using different substances, not the oats, but different materials. It's somewhat limited, but you can use this to time how long it takes different substances to interact and transfer energy, or if there's a difference between what's happening at different temperatures. Most people will use the generic mode, which would represent water or air molecules. So, depending on what type of experiment you did, if you used small, medium, and large mama bear, papa bear, baby bear size samples, then you can use small, medium, and large samples to run your experiment. So, for example, if I'm going to add a small sample and my water in my experiment was about 82 degrees Celsius, so I'm going to get it as close as I can, which was 79.5 in the simulation. I could keep going, but then I think it goes up to 90. So I'm going to keep it down by 79.5. Now, my samples were sitting in the room, sitting out. And so I am going to add a large sample to represent the air in the room. And the air in the room was at room temperature, which is 25 degrees Celsius. So I'm actually going to leave that the way it is. Now, in your lab notebook, you actually have a place to write down observations. So I have my graph. Below that is a space where you can write down what you did, what you observed, and I'll show you some different features you can look at in the simulation. But there should be plenty of space, and you can always use another piece of paper if you need more. So let's say that I am exploring what happens to the small beaker in the air. I'm going to push those together and speed up the time. And I notice that the energy is transferring from the hot water sample to the cooler room temperature air. They're getting pretty close to equilibrium. Not quite there. There we go. Now, a couple things to notice. The thermal energy of sample B is much higher. That's because there's more molecules in sample B than sample A, and so there's more total thermal energy, total kinetic energy. Sample A has less thermal energy because it's a smaller sample, but they're the same temperature. Because we've let them mix together, the energy is transferred from A to B, and now they're at equilibrium. I can also click on Analyze, and when I look at this graph, I'm going to go back to the beginning here. When you speed up the time, it actually collects quite a bit of data. There we go. So right at this point, you can actually see a little video of what I did is where they came together. And so I could measure the time at 72 seconds until it reaches equilibrium, which was right here. It's about 1:33. So I could write down the time difference that I noticed it took for sample A and B to reach equilibrium. And then I could do the same for a medium and a large sample. Or I could write down the temperature they were at equilibrium, which is 38.6. There's a lot you can do, so have fun checking out the particle level.